Studying the structure of atoms is little like studying wind. Because you cannot see air, you must use indirect evidence to tell the direction of the wind. Atoms pose a similar problem because they are extremely small. Even with a microscope, scientists cannot see the structure of an atom. If you cut a piece of aluminum foil in half, you have two smaller pieces of the same shiny, flexible substance. You could cut the pieces again and again. Can you keep dividing the aluminum into smaller pieces? Greek philosophers debated a similar question about 2,500 years ago. The philosopher Democritus believed that all matter consisted of extremely small particles that could not be divided. He called these particles atoms, from the Greek word atomos, which means uncut or indivisible. Aristotle thought that all substances were made of only four elements: earth, air, fire, and water. He did not think there was a limit to the division of matter. For many centuries, most people accepted Aristotle's views on the structure of matter. By the 1800s, scientists had enough experimental data to support an atomic model. What was Dalton's theory of the structure of matter? Dalton proposed the theory that all matter is made up of individual particles, called atoms, which cannot be divided. Evidence for atoms. John Dalton studied the behavior of gases in air based on the way gases exert pressure. Dalton correctly concluded that a gas consists of individual particles. Dalton measured masses of elements that combine when compounds form. The ratio of the masses of the elements in each compound was always the same. In other words, compounds have a fixed composition. When magnesium burns, it combines with oxygen. In magnesium oxide, the ratio of the mass of magnesium to the mass of oxygen is always about 3:2. Magnesium dioxide has a fixed composition. Dalton's theory. All elements are composed of atoms. All atoms of the same element have the same mass, and atoms of different elements have different masses. Compounds contain atoms of more than one element. In a particular compound, atoms of different elements always combine in the same way. Dalton made these wooden spheres as a model to represent the atoms of different elements. A tiny solid sphere with a different mass represents each type of atom. A theory must explain the data from many experiments. Because Dalton's atomic theory met that goal, the theory became widely accepted. Over time, scientists found that not all of Dalton's ideas about atoms were completely correct. They revised the theory to take into account new discoveries. Thomson's model of the atom. What contributions did Thomson make to the development of atomic theory? Thomson's experiments provided the first evidence that atoms are made of even smaller particles. When some materials are rubbed, they gain the ability to attract or repel other materials. Such materials are said to have either a positive or negative electric charge. Objects with like charges repel or push apart. Objects with opposite charges attract or pull together. Amber is the hardened form of a sticky, viscous liquid that protects trees from insects and disease. If amber is rubbed with wool, it becomes charged and can attract a feather. Thomson's experiment. In his experiments, Joseph John Thomson used a sealed tube containing a very small amount of gas. When the current model was turned on, the disc became charged and a glowing beam appeared in the tube. Thomson hypothesized that the beam was a stream of charged particles that interacted with the air in the tube and caused the air to glow. Thomson observed that the beam was repelled by the negatively charged plate and attracted by the positively charged plate. Evidence for subatomic particles. Thomson concluded that the particles in the beam had a negative charge because they were attracted to the positive plate. He hypothesized that the particles came from inside the atoms because, no matter what metal Thomson used for the disk, the particles produced were identical. The particles had about 1/2000th the mass of the hydrogen atom, the lightest atom. Thomson's model. Thomson revised Dalton's model to account for these subatomic particles. The atom has neither a positive nor a negative charge, but there must always be some positive charge in the atom. The atom is filled with a positively charged mass of matter that has negative charges evenly scattered throughout it. Thomson's model of the atom is called the plum pudding model. Today it might be called the chocolate chip ice cream model. The chips represent negatively charged particles, which are spread evenly through a mass of positively charged matter, the vanilla ice cream. What contributions did Rutherford make to the development of atomic theory? According to Rutherford's model, all of an atom's positive charge is concentrated in its nucleus. Rutherford's hypothesis. Ernest Rutherford designed an experiment to find out what happens to alpha particles when they pass through a thin sheet of gold. Alpha particles are fast-moving, positively charged particles. Based on Thomson's model, Rutherford hypothesized that the mass and charge at any location in the gold would be too small to change the path of an alpha particle. He predicted that the most particles would travel in a straight path from their source to a screen that lit up when struck. The gold foil experiment. The alpha particles whose paths were deflected must have come close to another charged object. The closer they came, the greater the deflection. However, many alpha particles passed through the gold without being deflected. These particles did not pass close to a charged object. Thomson's model did not explain all of the evidence from Rutherford's experiment. Rutherford proposed a new model. The positive charge of an atom is not evenly spread throughout the atom. Positive charge is concentrated in a very small area. The nucleus of the atom is a dense, positively charged mass located in the center of the atom. The Houston Astrodome occupies more than 9 acres and seats 60,000 people. If the stadium were a model for an atom, a marble could represent its nucleus. The total volume of an atom is about 1 trillion times the value of its nucleus. Assessment questions. Number 1. Dalton's theory did not include which of the following points? A. All elements are composed of atoms. B. Most of an atom's mass is in its nucleus. Or C. Compounds contain atoms of more than one element. Or D. In a specific compound, atoms of different elements always combine the same way. The answer is B. Most of an atom's mass is in its nucleus. Number 2. J.J. Thomson's experiments provided the first evidence of A. Atoms, B. A nucleus, C. Subatomic particles, or D. Elements. The answer is C. Subatomic particles. Number 1. The concept of an atom as a small particle of matter that cannot be divided was proposed by the ancient Greek philosopher Democritus. True or false? The answer is true. Thank you for watching and listening to section 4.1, Studying Atoms.